All right, so this is the problem that we left off with. We were just getting ready to start this when class ended. It says given segment ST is parallel to segment QR. So this segment up here that's 15 is parallel to this segment right here, QR. Determine the length of PS. So since I don't know how big PS is, I'm going to call it X. I notice that this parallel segment that's inside my triangle is touching the sides of my triangle at S and at T. I have a variable this way above S, and I have 6.4 below S. So I have two pieces that I could make a fraction out of. And I have the same kind of thing over here at T. I know that above T is 12 and below T is 8.2. So I'm going to take these pieces right here and make a fraction. This was the triangle proportionality theorem that we learned yesterday. So when you have a segment inside a triangle that is parallel to the third side, it splits the sides of the triangle, the ones that it touches, into proportional segments. So we turn them into fractions. So I would have X over 6.4 is equal to 12 over 8.2. You have to make sure that these two pieces end up in the same fraction, or same part of the fraction, and these two pieces end up in the same part of the fraction. So 6.4 and 8.2 are both those little segments, and so they are both in the denominators. All right. We're going to multiply both sides by our denominator of 6.4. So it cancels out over on the left. It only multiplies to the 12 in my numerator. So I have X equals, what is 12 times 6.4? What's 12 times 6.4? 76.8 over 8.2. So now we're going to take 76.8 and divide it by 8.2. And that gives us what? 9.365 if we take it out to 3 decimal places. We let X stand in for PS, so PS is equal to 9.365. Part B says find the length of PQ. Well, PQ is what you get when you put PS together with SQ. We just figured out that PS is how big? 9.365. And if we look over on the picture, we can see how big SQ is. How big is SQ? 6.4. So then we add those two together to get the length of PQ. 9.365 plus 6.4 gives me 15.765. All right. I'm going to look down at numbers 5 and 6. That is the converse of the triangle proportionality theorem. The converse of the triangle proportionality theorem says if a line intersects two sides of a triangle and it separates the sides into proportional corresponding segments, then the line is parallel to the third side of the triangle. So we're going to use this to figure out whether or not a line inside of a triangle is parallel to the side that it does not touch. It says here on number 5 that YL is 5. So I'm going to add that to my picture. YL is 5. LX is 20. LX is 20. Then it says JX is 4 times as long as WJ. I don't know how big WJ is, so I'm going to call it X. And if JX is 4 times as long, what could I call that? 4X. We are going to use these to make fractions now and see if they come out to be the same. If they come out to be the same, then the lines are parallel. So we're going to make a fraction with each of these pairs of numbers. So I would have 4x over x. And I want to know, is that equal to 20 over 5? Again, I have to keep these two pieces in the same part of the fraction and these two pieces in the same part of the fraction. So x and 5 should be on the same side of the fraction. They're both in the denominators. And now I'm going to divide. What is 20 divided by 5? 4. Here I have x divided by x. I know there's a 4 up there also, but I'm looking at just this part right here. If x was a number, let's say x is 7. I'd put a 7 in both of those spots. What's 7 divided by 7?
1.
What about if x was 100? What's 100 divided by 100? 1. What if x was 1,000,000? 1. So these x's simplify to be just 1, so they're going to cancel out because I have 1 times this 4 right here. So I have just the 4 remaining. Those came out to be equal, and so the lines are parallel. Our work showed that they are parallel because when we set up our proportion of sides, it came out to be the same number on either side. Is it still wrong if you put what? If you put 20x? Oh, like if you multiply both sides by x and then multiply both sides by 5, you could totally do that too. Let's actually do that on the next problem and see how we could do it that way and get the exact same answer. All right, so it says PK is 34. 34. KQ is 20. PJ is 1.7 JR. I'm going to take JR and replace that with X. So PJ is 1.7 X. And then JR, I replaced JR up above with an X, so JR is X. All right, so we're going to make a fraction out of these. And we're going to make a fraction out of these. All right, so 34 over 20. We want to know, is that equal to, and then my other fraction would be 1.7x over x. I'm actually going to move all of that down just a little bit so that I have some more room to work with it. There we go. Let's multiply by our denominator of x first. Multiply both sides by x. That makes it cancel out from the right-hand side. It only multiplies to my numerator. So I would have 34x over 20. And I'm trying to figure out whether or not that is equal to 1.7x. And then we can multiply both of our sides by 20 to cancel out our other denominator. Cancel out my denominator on the left, so I just have just 34x on the left. What is 1.7 times 20? 34, so I get 34x here also. They came out to be the same. So what does that mean about my two lines? Yes. The lines are parallel. So we know that QR is parallel to KJ. If they didn't come out to be the same on both sides, then we would say the lines are not parallel. They won't always come out to be the same. These two examples they did, and you can do it either the way we did on the left or you can do it the way we did on the right, whichever one feels more comfortable for you. What you're looking for is, do the two sides come out to be the same? All right, let's flip this over to page 13. And we're going to talk about midsegments. A midsegment of a triangle is the segment formed by connecting the midpoints of two sides in a triangle. And midsegments have two very important properties. The midsegment is parallel to the third side of the triangle, and the midsegment is equal to half of the third side of the triangle. Yep. So it is parallel and it is half. So two important properties. Here's our first property, that it's parallel. And here's our second property, that it's equal to half that side, the side that it does not touch. All right, so let's look at a midsegment in a picture. Number 7, it says that D and E are midpoints. So D is a midpoint. Well, if D is a midpoint, then AD and DB would have to be the same size, because midpoints cut sides in half. E is also a midpoint. So AE and EC would have to be congruent, because again, the midpoint is cutting that side in half. Because D and E are both midpoints, this segment right here is the midsegment. And it is parallel to the side that it does not touch, BC. That's actually the first thing that I'm going to write down. Segment DE is parallel to segment BC. That came from our first property up here. Not only is it parallel, but what's the other property of a midsegment? It's not just parallel, but it's also what? It's also half. Yes, DE is equal to half of BC. Or another way of saying that is, if I have two segments the size of DE, that would give me a segment the size of BC. Right. I need to come up with 4 more things that I can say about this picture. Well, we said that D is a midpoint, right? D is a midpoint? Yes. So what's something that I could say about side AB? Like, what do I know about AD and DB? Yes, segment AD is congruent to segment DB. What would the relationship be between AD and this whole side over here? Yeah, there's two ADs in that whole side. So 2 times AD equals AB. Or another way to think about that is that segment AD is half of segment AB. Is there a similar statement that I could make about the other side? Yes. Yes. E is a midpoint, so what could I say over there? AE is congruent to EC, or I could say that AE is equal to half of AC. I'm going to go with the congruent statement, but I could write either one of those down, or I could write one on each line. There's one other thing that I want to say about this, though, because it's been a minute since we've practiced with this. If I take segment AE and I add that length onto segment EC, what will it give me? Segment AC. Nicely done. All right. Let's look down at number 8 next. So a couple things to look at in the picture. I see that BG and GC are congruent. If those two little segments are congruent, then what do we call point G? Midpoint. What would we call point F? F is also a midpoint, because CF and FD are congruent. What about point E? It's also a midpoint. So since G and F are midpoints, what do we call the segment that we get when we connect them? That's a midsegment. What would we call segment GE? That's also a midsegment, because it's connecting two midpoints. Are there any other midsegments here? Yes, EF is also a midsegment. The midsegment is half of the side that it does not touch, correct? Well, look down here at side BD. I have two segments down here that are the same size, right? And it takes two of them to make this whole side. So half of that would be just one, right? This midsegment is half of the whole side, so it's congruent to just one of these little segments. So up here, GF is congruent to BE and to ED. GE is half of this side over here, and there's two segments, CF and FD, that are the same size. So GE is the same size as CF. GE is the same size as DF. And then the same thing is true here with EF. All those little midsegments are congruent to half of the sides that they are across from. If GE is equal to 8, so this guy right here, if that is 8, how big is CD? Right over here. 16, because this would be 8 and 8. So together that would be 16. 2 times 8.
I don't really understand how GE is a part of CD.
GE is not a part of CD.
So why is it marked with the same congruence?
Because we said the midsegment is half of the side it doesn't touch. So this is a midsegment. It's half of the side that it does not touch over here.
Oh, okay.
So this is congruent to half of this side.
Right.
Does that make more sense?
Yeah.
Good.
So the third side isn't touching with the other side?
The third side does not touch my midsegment.
Okay.
The third side does not touch the midsegment. All right, part B says BC is 20. Well, here's BC. This is 20. If BC is 20, how big is BG? 10. How big is GC? 10. So how big is EF? Also 10. So EF is 10, half of 20. BD is 32.5, right here. 32.5. So how big is BE? 16.25. How big is ED? 16.25. So how big is GF? 16.25. It's half of 32.5. All right, last one on this question. Says that EF is x plus 2. So that would be this right here, x plus 2. And BC is 3x minus 8. B over to C, 3x minus 8. EF is a midsegment, and this would be the third side because it doesn't touch it. How many midsegments fit over here? 2. So 2 times EF equals BC, which means 2 times x plus 2 equals 3x minus 8. Now I'm going to take my 2 outside the parentheses and distribute it inside the parentheses. So I would have 2x plus 4 equals 3x minus 8. Get my x's to the same side by subtracting 2x from both sides. I would have 4 equals x minus 8. Then I'm going to add 8 to both sides. What is 4 plus 8? 12. So x is 12. How are we doing so far? Feel like we've been moving kind of fast too, but we need to today.
Okay, so it's just how do we determine if, let's just say, EF is half of the, it's half of BC? Is it because
If
of
E and F are midpoints, then EF is half of the side that it doesn't touch.
Okay.
That's what a midsegment does and is. That's one of its properties.
Okay.
So if we connect two midpoints, it will be half as big as the side that it's not touching.
Okay.
Yep. All right, let's look down at number 9. Same picture, so I'm going to add my same markings on here. We said that GF, which is a midsegment, is half the size of BD, so it's the same as each of these little pieces here. EF is congruent to each one of these little pieces here because it's half of that full side. And GE is the same size as each one of these segments because it takes 2 to make that full side, and GE is half of that. So I want you guys to make a note down underneath this picture. Midsegments create 4 smaller congruent triangles. And those small triangles are similar to the big triangle. If you look in this picture, I'm going to highlight these triangles for us so that we can see them. There's a little triangle down here in this lower left corner. It has 1 congruence marking on one side, 2 on a side, and 3 on the third side. When I compare that to this triangle over here in the right-hand corner, it has 1 congruence marking on one side, 2 congruence markings on a side, and then 3 congruence markings. So they're congruent to each other by side, side, side similarity. And then if you compare that to the triangle up here at the top, 1 congruence marking, 2 congruence markings, 3 congruence markings. It's congruent to the pink one and the blue one by side, side, side. And then this one in the middle. Do you guys see the white triangle in the middle? It's oriented differently. These 3 kind of look like stamps. I just picked one up and moved it and set it down in a different spot. It's oriented exactly the same way. But the white one in the middle is the top one rotated upside down, so twisted upside down. But it is congruent. There's 1 congruence marking, 2 congruence markings, 3 congruence markings. So by side, 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 it is also congruent. All right. Let's see if we can answer these questions here. It says that angle B is 48 degrees. So this angle right down here is 48 degrees. Notice that's where these 2 sides with 1 and 2 congruence markings on it come together and touch. What's another angle that would also be 48 degrees? FED, this angle right here in this corner, that would be 48. It's because this triangle is congruent to this triangle. Yep, that's what we learned first semester. Yep, that's a first semester thing. Give me another angle up here that would also be 48 degrees. CGF, this angle right here, would also be 48 degrees. There's one more, but it's a little bit harder to find. Yep, GFE, this angle right here. Notice it's where the 2 and 1 congruence mark sides come together. Remember, it's that purple triangle rotated upside down, rotated 180 degrees. So this guy here is 48 degrees. All right, so let's read the question. The question says, if the measure of angle B is 48 degrees, then the measure of angle GFE is how big? 48 degrees. Because here's angle GFE right here. All right, part B. Angle B is still 48 degrees, but now angle BGE, we're being told, is 73 degrees. B up to G, down to E. So when we say angle BGE, we're talking about this angle up here is 73 degrees. Because we have four little congruent triangles here, what's another angle that would have to be 73 degrees? C up at the tippy top is also 73 degrees. What's another one? Not D. Yep, EFD right up here. This guy would be 73 degrees. Notice these 73-degree angles are happening where the side with 1 and 3 congruence marks are coming together and touching. So where's another 73-degree angle in the picture? E, down at the bottom. That'd be GEF, right here. 73 degrees. All right, let's read the question now. Let's finish reading the question anyway. If angle B is 48 degrees and angle BGE is 73 degrees, then angle D equals, well, here's angle D. And to answer this question, I want to pretend like we can't see any of the rest of this picture since we've filled in all these pieces. I'm just looking at this little blue triangle down here in the corner. What do you know about the three angles inside of a triangle? They add up to 180. So if I add 48 plus 73, first of all, what do I get when I add those? 121. Then I can do 180 degrees minus 121 degrees to get this angle right here. How big would that be? 59 degrees. So angle D is 59 degrees. All right. Time to flip the page. Number 10. They give us some information, but notice there is nothing drawn or written on my triangle here. So we are going to have to add things to this picture. It says it's called triangle LMN. So we need to put those letters on our triangle. Do you want L to be on the top, the left, or the right? The first thing I heard was left. Does it matter? No, you get to set it up however you want. But here's what I heard first. So where should we put M? Top or right? Top, sounds good. And so N would have to go over here on the right. So all I did was I took the triangle name and I put it on my picture. Midpoints A on LM and B on MN. So I'm going to go find side LM and we're going to put a midpoint down and call it A. If that's a midpoint, what do we know about LA and AM? What'd you say? No, I want to know about this segment and this segment. Sorry, I probably wasn't clear. They would have to be congruent because A is the midpoint. It's chopping that side in half. On side MN, we have a point B that is a midpoint. So over here on side MN, I'm going to draw another point. We're going to label it B. It is also a midpoint. So what would that mean about MB and BN? They are congruent because B is a midpoint. It's chopping that side in half. All right, question A. Segment AB. Well, I don't have a segment AB, so let's go draw it in. Let's connect A to B. What would we call that segment since I just joined two midpoints? A midsegment. All right. AL is 62. So right here. MB is 3x plus 11. So from here to here, 3x plus 11. And then MN is 2x plus 55. So from M all the way to N, 2x plus 55. Well, I know that MB and BN are the same size, right? MB and BN are the same size. Yeah. How many segments the size of MB would it take to make the whole side of MN? 2. So 2 segments the size of MB equal MN. So 2 times 3x plus 11 is equal to 2x plus 55. First thing I want to do now that I've got this set up is I want to distribute that 2 inside my parentheses. So I would have 6x plus 22 equals 2x plus 55. Then I'm going to get my x's to the same side, so I'm going to subtract 2x from both sides. That would give me 4x plus 22 equals 55. Bring my work over here. 4x plus 22 equals 55. Then I'm going to subtract 22 from both sides. I get 4x equals 33. And then I divide both sides by 4. And this does not come out very pretty. 33 divided by 4 comes out to be 8.25. It's not that bad, but it does come out to be a decimal. All right. And then part C. Part C says if ln equals 200 plus 2w, so ln, this right here, 200 plus 2w, and AB is 43, so this right here is 43. What did we call AB again? A midsegment. What's the relationship between the midsegment and this side down here that it doesn't touch? Yeah, 2 segments the size of the midsegment, so 2 segments the size of AB is equal to that third side, is equal to ln. So 2 times 43 equals 200 plus 2w. 2 times 43 is 86, so 86 equals 200 plus 2w. Subtract 200 from both sides. I get negative 114 equals 2w. And then I divide both sides by 2. Negative 57, yes. Negative 57 is equal to w. All right. At least one more problem, 2 if we can fit it in, but I doubt it. Let's do number 11 next. Proportional parts of parallel lines. This is very similar to my triangle proportionality theorem. Proportional parts of parallel lines says if 3 or more parallel lines intersect 2 transversals, they cut off the transversals proportionally, so fractions. So since these three lines are parallel, we're going to take these two numbers over here, the 6 and the 5, and make a fraction. So 6 over 5. That will be equal to the fraction that we make from this side over here. 2m minus 1 over 3m minus 5. Make sure that you're matching up which ones go on top and which ones go on bottom. All right, let's get rid of our fractions. Let's get rid of the 5 first. So we'll multiply both sides by 5. Cancels out my denominator over here on the left. So I have 6 equals. The 5 only distributes to my numerator. So I would have 10m minus 5 over 3m minus 5. Then we multiply by our other denominator, 3m minus 5 on both sides. Cancels out my denominator on the right. On the left, we have to distribute this 6 to the 3 and to the 5. 3m times 6, that's 18m, minus 5 times 6, so minus 30, equals 10m minus 5. I get my m's to the same side next by subtracting 10m from both sides. So I have 8m minus 30 equals negative 5. Add 30 to both sides. What is negative 5 plus 30? 25. So 8m equals 25. Divide both sides by 8. And I get m equals 3.125. Very nicely done. All right. Let's check out number 12 real quick. I just want to look at it for just a moment. What does this mean? It means they're congruent, right? If they're congruent, then we're going to set them equal. Same thing over here. These would also be congruent, even though they're not marked. If the other side is congruent, this side is congruent. So we will set these equal. So I would have 2x equals 4x minus 10. And I would have 5y plus 2 equals 2x plus y. I would have to find x first before I could do the orange equation. The rest of this problem will be up in Canvas in the notes section if you would like to see how to finish solving this problem. Have a great rest of your day, guys, and I will see you tomorrow. Don't forget, homework is due tomorrow. Homework is due tomorrow.